Welcome to the Operations Science Podcast, where the art and science of operational excellence come to life through captivating stories of triumph, challenge, and transformation from the front lines of industry. Our distinguished guests, from manufacturing pioneers and medical device innovators to aerospace visionaries, diagnostic lab leaders, and major capital project leaders, unveil the hidden patterns and powerful insights that drive exceptional results in the complex world of operations. Join us on this journey of discovery as we explore the brilliant minds behind the systems that make our world work and uncover the leadership secrets that could revolutionize your approach to operations forever. Here is your host, Ed Pound.
Welcome to the Operations Science Podcast. The opinions expressed by our guests are their own and are not meant to represent their company's positions unless specifically stated. Now, imagine you're on a flight across the Atlantic on a Boeing 777 with nothing but deep blue ocean below you. You're enjoying a movie and settle comfortably into your seat. Did you ever wonder about the dedicated engineers who designed the specialized motors of the starter generator that keeps electricity flowing so you can enjoy your movie and, more importantly, so the plane flies flawlessly? Our guest has spent more than a decade at the leading edge of custom electromechanical innovation, designing and developing high-performance stators for some of the world's most demanding environments. From aerospace to defense and oil and gas, my guest has helped shape the future of mission-critical solutions. With a background in aerospace engineering and experience that started at John Deere before landing at Windings, he now leads product development at a company known for building some of the most reliable motor components in the industry. Please welcome Blaine Alderks. Hey, Blaine, how you doing?
Hey, welcome. Thanks, Ed.
All right, let's get right to it. There's lots going on in product development these days. What are some of the key trends that you're seeing, and how are they shaping your work at Windings?
Yeah, no, I appreciate that. Obviously, product development is a big part of what we do at Windings, and we're seeing a lot of changes over the last couple of years. Really, some of the key trends and things overall that we're kind of seeing in product development is a lot more kind of fast-paced, more agile type of requests from our customers. There's kind of if you probably heard it recently, a fail-fast mentality. There's a lot of try something, see what happens, and then we'll kind of learn from that and try again. So we're seeing a lot more people kind of trying to pursue that type of mentality as we go into product development. But we're also seeing a lot of customers in general wanting to have a lot more input into how their products are designed. They don't want to be buying a black box anymore in a lot of cases. They want to have some understanding or some knowledge or some ownership in kind of what is going into a lot of those products today, which is kind of where we fit in because we're bringing a lot of customization and customized nature to a lot of these products. And we work with our customers, and that's one of our biggest things is we work with them to figure out how can we work on this together to solve the problem. They have some expertise. We've got some expertise. How do we find the kind of good middle ground?
Interesting. Let me just cut in there for a second and ask about that fail fast, because that has a lot of implications for the capacity that you use in your process. So some people might think, oh, you're doing all these attempts and then they're not working, you're doing it again, and then that uses up your capacity more. Or you might look at the situation where it says, well, actually, by doing quick attempts, we don't get way down the road before we find out that something's not right. Which is it in your experience so far?
Yeah, what we're finding, I mean, we do get a little bit of both. I'm not gonna deny that, but what we do find is that finding solutions early tends to save us a lot more time further down the road. So being able to try something out, make sure that works or doesn't work, we can quickly and easily pivot before we get too far where things are locked down and we kind of have to just make things work. If you look at product development from probably 10, 20, 30, 40 years ago, we see a lot of stuff today that's coming back around because they had done that at the time, and they're asking us now, hey, we know this isn't the most efficient. Let's work through what can we do to make these a little bit better now.
Okay. Yeah, that's an interesting, from an operations science standpoint, interesting, because you are introducing some variability, but then if you're more efficient with your capacity because of that variability, you're better off. So that's interesting. So I know that Windings has been through a number of acquisitions. How do the acquisitions impact your product development process? Any lessons learned from recent integrations?
Yeah, I'd say kind of the biggest thing that we've run into with acquisitions is knowledge transfer, and it's both ways, I would say. Especially in product development, there's a lot of knowledge and know-how that's kind of tribal to how we do things. And it's really specific to our facility and what we're doing on site. So as we go out and acquire new businesses, and if they're similar or even different industries than what we're doing today, we're finding that there's a lot of learning that we have to do of what they're capable of doing, and how do we design and work with that team. But they're also learning from us to say, hey, you guys are experts in this, and things like that too. So how do we document a lot of the tribal knowledge that maybe isn't written down, and convert that? I'm going to say in both ways. Some lessons that we've really learned to kind of help address that, and maybe some of the missteps we had, is not having people integrated early enough in that process. So not getting those teams together, kind of saying, hey, yep, they got these group, they kind of sit over here. We got this group, they kind of sit over here. We'll figure it out eventually. But what we found is that the sooner we get them together, the quicker we can solve some problems. And we had a case, about a year ago with one of them that we had done, where they were churning on trying to solve a problem. And as soon as one of us, just took a matter of what is the problem, one of our engineers asking them, and they're like, hey, here's what we're running into. And it was something that we had actually dealt with, a number of years ago ourselves. So it was something that, hey, if we had talked a lot sooner, we wouldn't have maybe churned and burned so much time.
Right.
Again, back to how do we plan around that stuff? It's more efficient if we have everybody on the same page and we know what we're all capable of doing.
So a couple of questions about that in terms of when you get people involved. The way these acquisitions go is companies get interested, the executives start talking, the bankers are talking, there's a memorandum of understanding. Then the product development team and the rest of the organization kind of sometimes they don't get brought in until actually, signed on the dotted line. In your experience, would you say, how soon in that process do you think makes sense to bring the teams together?
Yeah, I mean, I'd say, there's a lot of legal things that have to kind of be ironed out before you can actually make a lot of announcements like that. So, I'd say as soon as possible after signing on the dotted line, getting those people to interface with the teams, and say, hey, we're not necessarily trying to replace anybody, but we're saying, hey, here's kind of how we want you guys to work together. Go out there, spend some time with them. And I know it's always a challenge, because people are always like, oh, now it's another thing to work on. But it's so much easier to say, hey, go, whether it's you go to them, they come to us, depending on how difficult or easy that may be. But I'd say as soon as possible, I'd say a matter of 30 to 60 days after that dotted line is kind of signed.
Sure.
To say, hey, let's just go out there and learn what they're doing, and how can we learn, and what can they learn from us.
So it sounds like then that, like, for instance, the example you just mentioned was longer than 30 or 60 days after the acquisition. How long was that in that regard, in that particular case?
Yeah, absolutely. It was probably close to 12 months after the acquisition when that kind of came up.
Oh, wow.
And I don't know if they've been working on it for that full 12 months period, but they've definitely been working on it for more than 30 to 60 days. So.
Right. You're right. So you're saying don't wait a year. Yeah, I got it. That makes sense. So while we're on this topic, I know the Operations Science Institute has worked with you guys. You did a wonderful job of applying operations science to product development, which is sort of a, non-typical, non-traditional application in most people's eyes. When you're doing these acquisitions, you're talking about, there's a lot of tribal knowledge. Is that in terms of technical knowledge, or do you also work with them in terms of their development process?
Good question. I would say for the most part, in our experience, it's been the technical knowledge. That's the tribal. Just in the way that we've kind of gone about our acquisitions, we still are maintaining a lot of the product development in our facility. So we're not trying to transfer as much product development knowledge. Maybe a few things kind of here and there as they work on new things, but we still are consolidating it. And that's probably the biggest challenge in transfer, is understanding maybe from their sites, what can we incorporate in our products today that we don't necessarily do on our site, but somebody else can help us do now. So what added capability we have.
Okay. All right. So then in terms of the acquisitions, the way it's worked is you've acquired their product line, their IP, but that's been consolidated within Windings, with some product development going on at the acquired sites. Is that a fair description?
Yeah, I'd say very limited product development at the acquired sites. It's more just manufacturing expertise that they're bringing to the table. Yep.
Okay, so then Windings maintains sort of the product development center of excellence, you might describe it.
Correct. Yep, that's correct.
All right, on a different topic, and the latest topic for many people is AI. How do you see artificial intelligence impacting product design and development in your job?
Yeah, AI is definitely a buzzword, really hot topic for us right now. We actually recently published a lot of stuff around how we use AI and setting some guidelines and rules for our teams because there is a lot of can we use it? What do we use it for? How can it help us? What is it? What are we at risk at? And I think there's a lot of trade-offs there, benefits and risks with AI. The biggest thing that we kind of run into is really just understanding what kind of implications we have in terms of confidentiality or IP ownership. So making sure that we don't have any exports or potential exports of information that might be going out to who knows where.
Exactly.
So that's definitely one of the concerns that we kind of have, and so we kind of temper a little bit of the excitement with the. We also have to make sure that we're mindful of controlling and maintaining confidentiality with not only our products but our customers' products. But we do see a lot of benefits to how we use it, and kind of where we see a lot of that coming into play is really kind of like an assistant, kind of sidecar to a lot of our engineers, and being able to utilize AI to help automate some more of the repetitive tasks that they are working on. Engineers are a very expensive resource, and being able to having them work on things that are like administrative or documentation is just not the best use of time. Unfortunately, every engineer has to do that at some point, but we can see AI as being a way to help us automate some of those things and simplify that or lessen the amount of time they have to spend on those types of tasks. So some of those things would be like we see it comparing documents. I know there's a lot of document comparators out there today, but that's a lot on text-based stuff. We've got a lot of drawings that we deal with that's hard for OCR to kind of work through that we've had in the past. But AI is a perfect candidate to kind of say, hey, we're seeing these things, and here's kind of the differences between these types of drawings.
Okay, so just a clarification for the audience, in case they're not familiar. What do you mean by OCR?
OCR is like optical character recognition. So a lot of that is around reading text, and there's a lot of websites you can go outside, and do Google searches for today. Say, hey, compare this document to this document, and it's looking at kind of the words, and maybe some handwritten text, and it's translating that into letters and numbers that the computer can read. On drawings that we deal with, kind of in the day to day, it's more it literally is what it is. It's a drawing. It's something that's hand drawn or computer drawn in some cases, and it may have text, it may have numbers, it may have symbols, a lot of different things that OCRs today have struggled with, and so AI can kind of help us automate interpreting some of those things, so we can automate. Hey, this is how what's changed over the time.
Yeah, that's interesting because a lot of the recent trend before AI was digital technology, with the idea of the digital thread, everything's supposed to be digital. What I'm hearing, though, is it sounds like a lot of your customers maybe are not sending you digital renderings. You're actually getting hand drawn. How deep is the digital technology when you're dealing with the customers?
Yeah, there is a lot of digital stuff, and that does definitely help. I mean, nowadays, most people are doing a new design, it is all digital, it is all on a computer. So I'd say if somebody's sitting down and designing something, it's going to be there. What we run into a lot, especially in our industry, with aerospace and defense in particular, we have a lot of really old legacy designs, and these are things that people are looking to either resource, or they're still trying to update things, and they still have them in that old hand-drawn format. These are things that were drawn in the 50s and 60s. So you're trying to interpret that, and it's it's a little bit more challenging to do today, and they're just updating maybe the old drawings, or even just leaving them alone. They don't go through the effort to convert them into all fully digital at this point. But we do also run into, they don't always send us all the CAD files. They maybe just send us a PDF with the print file. So although it was created digitally, exported digitally, we're still looking at at the end of the day, a PDF file in a lot of cases that doesn't have all the detail that we need.
Okay. So with continuing a little bit on AI, when you're having people use AI, you mentioned document creation, maybe some document translation. I'm curious if you're familiar with AI agents and you've incorporated that into the work that you're doing, where they essentially take some of the mechanics off your desk and use those.
Unfortunately, at this point in time, I don't really have anything specific. Where we're still trying to really feel out what's out there and what's going to be the best case for us.
Me too.
Yeah, we're finding stuff like there's the Chat GPTs and the Geminis and all the guys that are out there. Yeah, I'd say they do a lot of really interesting stuff all around text based stuff, and I've used that a lot just creating work instructions. But in terms of creating the more specific technical detailed information we're looking for, I can't say we found anything that's been a slam dunk there yet.
Yeah, that will be interesting to see how that goes. The promise is there, but it's the Wild West right now, and everybody promises everything. So it'll be interesting to see how that develops. Okay, so let's talk about the product development process, maybe from an operations science standpoint, because maybe readers or our readers, our audience might not be familiar with the application of that to product development. How do you look at capacity planning and lead time management as part of your product development process?
Yeah, really good question. It's really an interesting challenge for us in particular, mainly because at Windings, our development cycles are typically very long, with a lot of ups and downs and ebbs and tides to kind of the work content that kind of goes on. And we're talking usually upwards of, it could be anywhere from 18 months to 24 months to kind of get from a product ideation through getting either the first prototypes or even the initial production kind of up and running. So for us, trying to understand where that work content is the biggest thing, because not that entire time doesn't require the same level of effort consistently. Oftentimes for a lot of the product development, we're very heavy front loaded on a lot of the engineering effort. We may be spending a lot of our time there, and then that'll kind of dissipate for a while. Maybe we go into product. We do the design. We then go buy some materials. Material lead times are going to drive less effort on our side, and then it'll pick back up when stuff kind of starts getting built again. So what we kind of do, and the way that we've kind of been looking at capacity planning for that, and taking some of the concepts from operation science, is breaking that down into smaller time chunks. So instead of looking at a whole project as kind of a whole that says this is going to consume somebody's time equally for the next 12 months, we'll break that down into smaller chunks. So what does that look like for the first, it depends on how long the project is, maybe the first couple, weeks, or maybe we'll break it down by month to kind of say this is kind of where we're expecting the work, and then we'll kind of shift their product load into those different work buckets. So we can kind of say we think the first block of work is going to take us 6 weeks to get done. That's going to take 80% of that person's time. Then they'll be dropped down to maybe 10% for the next 6 weeks block or whatever that is. And so we'll plan around a lot with that, and that allows us to assign that then out to each individual engineer that's kind of working on a project, and we can kind of look at that then as a sum of how much time in that time period are they consumed with project work or not. And then that's how we can kind of look at terms of, as new products come in, we can start blocking out that time for those engineers looking at it. So say, hey, we got a new project coming in. I can now easily see, hey, yeah, I got an engineer who's not available for maybe 2 weeks. His time frame will open up. We'll be able to slot it in there, or maybe it's another 8 weeks before that person's going to be available, and we can kind of use that in our lead time planning for new projects as they come in.
Right. So that's an interesting thing, because one of the observations from product development in any engineering, any sort of knowledge work, is that there is work in process. And so all the relationships between work in process and throughput and variability and lead time or cycle time reply is just different. It's virtual work in process. And so are you able then to, since you've embraced that approach, and that's absolutely brilliant in terms of breaking it down into specific tasks, it's a bit of, in my experience, it's a bit of an art to break it down. What level of granularity do you want to go to? And my rule has always been, go to the level that's useful and it's not too onerous. What people, in my experience, tend to do is what you mentioned that maybe people do at the beginning, is they just look at the whole thing, and then we got a number of engineers, and then we'll let them figure it out. as you get into more granular levels, you get better visibility about that. So with that approach, then, are you able to project capacity requirements over some period of time that you use? Hiring an engineer and get them online, that takes some time. Talk about that in a little bit in terms of long-term capacity planning.
Yeah, absolutely. And that's one of the reasons, or one of the secondary reasons why we implemented something like that, to help us realize what is our future projection look like. As I mentioned, our product development cycles are very long. And as you mentioned, it also is very long to get an engineer on board up to the level that we need. So we actually look out, we're typically looking at about 12 months, I would say, is kind of what we're trying to project out. I'd say realistically, the last 6 months is probably very unformal, unconfirmed. Where the initial probably 3 to 6 months is a little bit more well known for us. One of the things we do is we do populate in there kind of projected projects, and so like I said, we'll try and set aside some time and say if all of these projects hit, or maybe here's the high probability projects, we can see where they're going to hit and if that's going to overload us, like I said, up to about 12 months into the future. Like I said, we do see a lot of ebb and flow. So the hardest part for us is kind of staying on top of that and saying, okay, now this project, we're now into this low tide period where there's less work for that engineer to do. We have an estimate of when it'll pick back up, but as we've seen in often cases, there's delays, whether it's supply chain, customer driven, or even capacity on our side, as maybe another project got done sooner, and that allowed us to kind of pick that person back up again. And so we do have to do a little bit of shuffling kind of as we go in the near term, saying, okay, yep, actually, I thought this person was going to be available. Now they're not. We got to, slot them either a little bit later or something like that.
So, and just real quick, how often do you review that? Is it once a month, once a week, once a quarter?
Right now, I'd say it's inconsistent, but I try to get to it we've been trying to get to it about once a month. It's probably more like once a quarter right now.
Yeah. Yeah. Well, obviously that's driven by, what information you need. But the thing is to repeat it and to keep doing it, because that really provides some predictability. All right, cool. So you guys, the audience might not realize this, but we worked together for, I don't know, maybe about 6 months, and we were working on bringing the engineering organization up to speed on operations science and how that applies to product development. We were focused more on sales order processing, not product development specifically, although there's a lot of overlap. Speak a little bit. I'm very interested now that it's been, I don't know, what was that, 2 years ago, something like that, 3 years ago? It was a while, in terms of what changed from before and after you applied those or learned the operations science concepts.
Yeah. So yeah, obviously it was a fairly long process for us to kind of get that implemented. I know we spent a lot of time with you guys trying to map out our process flows and really build what that looks like. But after that, what's really changed is, after I've implemented, there's a lot more awareness, I'd say, in our organization to what is going on and how are we looking at the process flow and the constraints associated with it. So we have certainly still continued we've developed a kind of our sales order tracking, I would say, that's still maintained, and we look at kind of orders that are coming in, orders that are going out, and where's our bottlenecks kind of showing up. The biggest thing that we've probably also started to look at is the escape tracking, and that's been probably one of the biggest helps for us, is implementing that and really understanding what is causing us to stop or slow things down in the process. What's preventing people from being able to do their work? And we are still working through a lot of that today, to be honest. We're still finding a lot of things that could be improved, and that's really helping us drive our process improvements and documentation. We've also found that as new people have come on board in the last couple of years that we need to have better documentation on what those things are and how to catch them sooner. Like I said earlier, a lot of tribal knowledge exists within our team, and getting that converted into somebody who's brand new, never dealt with it before, they tend to have a lot more escapes. And so that's been really helpful for us to say, okay, how do we got to help train this person? And then, now we're starting to talk about how do we document that in a more formal way so that as new engineers come on board, we can say, hey, here's the stuff that you got to make sure you know going forward.
And does that include like some of these concepts of operation science, or is that just something that you call rework or escapes?
Yeah, we really just call it rework and escapes. We don't really put it under that concept of operation science at this point, but the people who kind of manage the schedules and the workflows are very familiar with that.
Yeah, well, I think that was one of the realizations. There's a couple of implications to that. One is on the rework, you're able to show, and engineers love math, right? You're able to show mathematically the effect of rework, which is really can be pretty devastating to throughput. And throughput in your particular process is getting sales orders through in a timely fashion, because if it's taking longer than everybody else, all the competition, that puts you at a disadvantage. The other point is, once you understand that effect, then it becomes ingrained in what you're doing, and you don't have to call it lean or operation science or anything. It's just kind of like, look, guys, we can't have rework. Here's the reasons, and that's what affects how it affects what we're doing. So
Yeah, absolutely.
that's a good lesson. So, what advice would you give to someone trying to improve engineering workflows without adding a lot of extra work?
Yeah, this it was a big learning experience for us kind of going through this and just figuring out how do we want to go about this and start implementing different process improvements and who really needs to be involved. Few pieces of advice I'd give is somebody's trying to do the same thing, involve the full team who is responsible or completing those workflows tasks today. One of the things we learned a lot of is that we have about 4 or 5, depending on the project scope, people who kind of touch the workflow. And we found a lot of people were duplicating in work because one person didn't necessarily know what the other was doing. And so having that full team picture to map out the process and say, okay, here is down to the very last thing that I'm working on. Like, this is how I do my process. And somebody else saying, oh, I'm doing that over here as well. And so finding ways to, those are the low hanging fruit that we could easily kind of start cutting out and say, yeah, don't do that here or do it over here. Or somebody's doing something very related later on. And we say, hey, let's move that ahead and put this into this person's tasks because it's much more aligned with what they're kind of already doing. And that saves us some time later on.
Yeah.
So yeah, having the team, really having that full team involved, and kind of with that, I think putting the time and effort into really mapping out that process, and I think using specific examples really helped us kind of get through a lot of that. Having that detailed model for what our process looks like allowed us to really understand what's going on, and then that helped us figure out what do we really want it to be, what is our ideal state at that point in time. And so instead of trying to jump from today to ideal state in, a short period of time, what that helped us do is identify those low hanging fruit items and also figure out, okay, where do we want to start tackling different parts of our process? So, not thinking that you have to solve it all in one go by rolling out a brand new process that touches absolutely everybody. Pick it off in pieces is kind of my advice as well. Find those things that you can kind of work on and tackle and start getting some momentum on, because you're going to start seeing that change a lot faster. And then people are going to want to know more and more and more. How do we keep going? How do we keep getting better here? And you can start implementing some of the bigger changes as you go after that.
Yep. Yeah, definitely. All good advice. So how does this affect how you deal with manufacturing? Is there any overlap, or you just kind of throw it over the fence, or how do you guys work together from the product development and interface with manufacturing?
Yeah, great question. That was one of actually a big issue for us relatively quickly after implementing this process. Actually, was we solved a lot of things, and then it looked like we were just kind of shoving things over the fence to our manufacturing team. And so one of the things that we've done in the last year, I would say here, is we've really started optimizing that process to bring more of that manufacturing engineering into our product development process. And that's where we maybe add some more people and we add some more review steps, milestones kind of along our way as we kind of call them to say, okay, we've got maybe 80% of what we think is ready to go. Let's go talk to our manufacturing group, get a team together, do that review process, and they can help us finalize the last 20% there. And in some cases, we may even go further than that and say, let's not only involve the manufacturing engineers, but let's involve the team who's going to be working on the operators on the floor. They're really our process experts in how we're going to put this thing together and get their input on what's going to work best or what do we need to be cognizant of. So
Well, that's interesting, because there is, you mentioned milestones. And so a very common process used is the stage gate process, where people are like, oh, we got to get to this gate. And then once we get to the gate, we make some sort of decision, we go forward. And there's some unintended, undesired behaviors that can result from that, where people are like, okay, let's just get everything we need to do to get to the gate and get through the gate, just so that we can say we got through the gate. But when you're using milestones like you described, where you agree on a number of tasks, and as you mentioned earlier, that you're also getting into a level of detail, because if people want to just say, well, it's just design and then engineer and then, fabricate, that's too high a level. And then you need to get down to some level of granularity where people have specific tasks. And then, to your point, rather than getting to a gate to say, oh, let's just get through the gate, you get to a milestone where, okay, now we have to bring in other people to make sure that we're meeting the requirements that we need. It's a subtle difference, but it's an important difference. Reflect on that for me a little bit.
Yeah, absolutely. It is kind of a subtle difference, and kind of what we're doing is I'd call it a little bit of a hybrid with a stage gate plus plus this kind of milestone mentality on a schedule. There's definitely benefits to the stage gate, and we've seen it kind of flip the other way, where people aren't necessarily rushing to the gate to get it signed off, but we're maybe just saying, it doesn't really matter. Let's just keep going. and and we get too far down the process where, we're like, well, did we check these other boxes as well? And so we maybe moved too fast in those cases. And so so we've kind of created a little bit of a process flow, and we're still in the middle of kind of developing and rolling this out today, which is saying, okay, here's kind of the inputs and outputs we want going up to each gate, but we're going to have a set of milestones that say, here's what we're really trying to accomplish, and that may allow us to say, hey, we can move on if we hit this milestone that enables this path, or this milestone enables us to go down this path. And once we get all of our milestones, we can say, yep, we're good to go on to kind of the next stage at that point.
Yeah, an unintended consequence of the stage gates, if you have sort of too much that has to happen before you get to a gate, that essentially results in accumulation of WIP, and WIP being, tasks in process. It's not physical parts moving through the system, but there's plenty of tasks. And when you look at it from an operations science standpoint, it's really, you're looking at how much time you're accumulating before you need to move forward, and time on your resources. In your case, as engineers, in manufacturing, it could be on machines. But to your point, breaking it down into smaller tasks, managing that WIP helps you maintain the flow a little bit better, except sometimes people get ahead of the game, as you mentioned. But again, that's a control process. Do you look at these tasks as a WIP management process? Talk about that a little bit.
Yeah, that's kind of where we're at today, and kind of developing that process is how are we going to look at that, and how are we going to kind of manage those tasks as a whole. Overall, today we're still doing a lot of that, and it's in our project management process, but we don't have it kind of integrated into our overall product development task flow yet. So that's some of the things we're still trying to figure out, is what needs to go into here, what doesn't need to go into there. And to your point, we don't want to make it so onerous that there's so many tasks going into it that we almost get ourselves bottlenecked just trying to get into that process flow. We also acknowledge that in product development, there's a lot of unknowns that still have to kind of be figured out too. So we don't need to have, we want to have some flexibility in that process and what we do and how we move through it, to say, these are the things we know we need, but we're not going to know them until we get to this point further down the line, and gain some of that acknowledgement and understanding from the team. And the whole point is, let's hit that milestone saying, okay, here's the things we now need to figure out later. Are we all in agreement we're okay to move forward? So instead of trying to figure it out and let people sit and wait for those last few details to be ironed out, we're going to still move on with acknowledgement that, yep, we're still going to figure some of these things out later on in the process.
Right. I mean, that's just the nature of the beast, right? That's the way the product design process goes. There are a lot of unknowns, which brings me to the question of this idea of commitment reliability, where, you're sitting, you're doing a planning meeting weekly. The idea with commitment reliability is you get people to say, oh, here's what I'm going to do this week. And so then you have an idea of how many hours they have. And then you see what they've done at the end of the week. Now, if you're working on a construction site where it's very important day to day to coordinate, you can look at commitment reliability from one day to the next. And if you're not tracking it, studies have shown that, your commitment reliability could be as low as 50%, where so contractors on a site will say what they're going to do that day, and then at the end of the day, you see what they did, and they only get half of it done, which is really bad for forecasting. It basically introduces a lot of variability. And from an engineering standpoint, though, you wouldn't do that daily because, as you mentioned, there is so much going on for an engineer to say what's going to happen one day to the next is just, it's too tight of a box to put them in. So you might look at a week. I'm wondering in terms of how you're managing your processes. Does Windings have weekly management planning meetings for engineers, or what's the cadence of that?
Yeah, no, you're absolutely right. From an engineering perspective, there is almost too much going on to try and do it in one day. And with the nature of the nature of development, the nature of just our business with supporting a lot of production, there's a lot of things that come up that you didn't plan on or didn't know or weren't aware of kind of going into the week or into a day even. So we do have kind of a schedule where we review these things on a weekly basis. And the thing I would say is, what I like to do is look at the next week, but also say, okay, here's what I'm committing to this week, and then what's maybe the following week look like. Maybe not a commitment, but what is coming up, so that we can have some idea of, hey, if you're done early, what can you pull in, or if you're going to be delayed on some things, do we have capacity in the next week to pick that up or make that up? I find that going any further than that it's really not beneficial. And really, even into the second week, there's just so much change and so much going on, and just the human nature of it. People find it hard to commit to something 3 weeks from now because they'll say, "I'll just do it the day or the week before, whatever it is," and it's not a really good commitment. So, but yes, we do a weekly kind of review Mondays with the team to kind of say what's going on, what are we working on, and then we have kind of a more higher level management review that happens after that to say, are we still working on the right priorities week to week, so that we're not constantly changing priorities or not working on the wrong things.
Yeah, no, I think that's brilliant. Actually, I mean that in the operations science context, you're what you're doing is you're managing your virtual queue. So you have sort of hard tasks or hard commitments for a particular week, but then you've got all this other stuff stacked up coming down the line. As you mentioned, you're not going to look 3 weeks out or a month out because you've already kind of looked at that from a rough cut capacity planning aspect, and you think you have the engineers you need, and then you're going to deal with the stuff this week, and then you're kind of looking at what's coming the week after. But that's absolutely a wonderful way to handle it, and that's a good WIP control process, and just having that idea that, well, actually I do have WIP. It's task. It's not parts. So
Yep, absolutely.
So what was that process like at Windings? If you just relate to I mean, when we came walking in the door, you didn't know us from Adam. So how did that go in terms of incorporating operations science into what you were doing?
Yeah, I mean, the way that the process worked kind of before that, it was, I wouldn't say free for all per se, but it wasn't very far off from that. We did have some sense of, we know that there's a process flow, and we did have process steps, and there was activities that people had to complete for a lot of that stuff. But is in terms of how we plan it, how we release it, how we schedule it, how we capacitize it, um, and track the commitments was really not part of our process flow at that time. So new orders would come in, we would just dump them right into the flow. They got worked on whenever they got worked on. Um, if we got 10 new orders on one day, they all went in and said, figure it out. So so yeah, I'd say we ended up seeing a lot of things that were really late. They took a long time to kind of do. There was a lot of not so much collaboration amongst the teams. So it just kind of was, I did my task and I threw it over the fence, and not really understanding maybe what they were going to be doing with it or what we needed to make sure was included. So bringing in the operation science stuff was really a way for us to kind of structure that in a little bit more of a methodical way, as opposed to just saying, hey, throw it out there, and whoever's going to yell the loudest is going to get their stuff done. This is going to say, hey, here's how we're going to handle these things, and we're going to have a meeting to review our, the priorities and the scope of work and the time frame that things need to be done in.
Yeah, and the thing about the operation science and dealing with product development and with engineers is, they like math. So you don't have to come in and say, oh, you just have to have faith and believe. It's like, no, this is the way the mechanics of your process works. You can choose to control it poorly, or put some structure to it. And we found this at Windings. We find this all over is that, once people get their minds around that, boy, you just stand back and watch them go.
Yeah, yeah, absolutely. I mean, the numbers and like I said, the methodical process to it really helped us understand it. You still end up with some of the engineers saying, well, it depends on this, that, and the other thing, and a lot more variables kind of going into it. But I think that's one of the things that was really helpful for us is to think through, okay, what are those things, and how do we plan for that, and how do we take that into account when we build our model at that point?
Right. I mean, that's always a constant a challenge, particularly with engineers, and the point is the model is not the goal. You don't want to you don't want to spend all your time getting the perfect model, as we've talked about earlier. There's that art and science to it, but having that structure, engineers can say, well, what about this and what about that and what about the other? And the response is, well, you can model it like that if you want to, but today is Wednesday and we need to get to work. So what are we going to work on in the context of understanding the behavior of our process? All right, excellent. Well, let's switch gears a little bit. Let's hear about your background, how you got to where you were. What was Blaine the kid like growing up? What brought you to engineering?
Yeah, no, absolutely. Yeah, my background, I grew up in a family with two other brothers, so we were a very masculine family, I would say. A lot of sports, a lot of competition, a lot of.
Now, are you the oldest, youngest, or middle?
I am the oldest. Yep,
Okay.
yep. So I was the one who had always felt like I was against, and my brothers got everything a lot easier than I did.
Okay. All right.
But yeah, I grew up, in Minnesota here in the just south of the Twin Cities. And really what I got me into aerospace engineering and really engineering in general is just kind of an understanding of trying to figure out how things work and using your hands to make them, hands on, make things actually happen. It's great. I definitely understand the theoretical nature of things, but getting into how does that translate to what I'm going to put down in front of me was really what kind of drove me a lot into engineering in the first place. And from there, I kind of was like, yeah, when I was looking at what I want to do when I grow up, if you want to put it that way, I was one of those. I wasn't really sure when I got to the end of my kind of high school career, and I started doing a lot of research and knew I, was really into mathematics and this hands-on type stuff, really engineering. But what engineering did I want to do? And that's when I came across kind of the aerospace engineering, as it offered a broad, really, in my mind, aerospace engineering offers a really broad expertise. There's a lot of different things that go into that. I love, airplanes. I love space. There was definitely a connection with that, and just trying to figure out, problem solving. And that's the thing that I felt aerospace engineering really brought me into, is more of just understanding how to solve problems. Yeah, they may be in space and they may be on a plane, but you're solving problems for something every day, and not getting yourself necessarily kind of pigeonholed into something else or something where you're working on one thing all the time. So for me, the variety and opportunity to do a lot of different things is really what brought me into kind of the aerospace world from there. So yeah.
So in terms of influences, I mean, is that in your family, your mother or your father, were they influences in that particular regard?
Not necessarily. They obviously would, they promoted me into doing whatever I felt like I kind of needed to do, but they weren't necessarily in the engineering world either, but it just so happened to be something that kind of that I really enjoyed and really loved working on.
Okay. So did either of your other brothers become engineers?
All of them did.
Oh, wow. No, so that's interesting. I wonder, that's interesting. Any ideas why that happened, or they just saw what you were doing and thought, wow, he's not going to be better than me?
There probably is some of that. But yeah, I think they saw some of what I was doing. I think they also had a similar mindset in a lot of cases, just with the way that, my family kind of let us figure things out and worked on them. And, that's one of the things that I really appreciated is not necessarily saying you have to do this one thing.
Uh-huh. That's awesome. That's awesome. Well, your parents must be very proud of all of you. That's quite an accomplishment. We need more engineers.
I can agree with that.
Yeah. So, in terms of your personal journey, how has that influenced your leadership style now that you've been in industry for 10 years and kind of, no longer a green thumb?
Yeah, absolutely. The really coming up through the engineering organization, it really helped me probably look at stuff in a little bit more pragmatic approach, a little bit more realistic. I definitely have kind of a mentality of trying to figure things out and solve those problems. And so that when I kind of translate into leadership, I really want to help other people figure out how those things can be solved as well. But I want to be realistic about it too. I don't want to say, hey, we're just going to throw some big, goal out there that we really have no idea what it means or how we're going to get there. I'm going to be realistic to say, okay, here's what we're trying to do, and then I'm going to work with, within myself or within my team to break that down into what are the specific tasks and goals and objectives that we're going to kind of focus on to be able to achieve that. So I think having that engineering mentality kind of helps me think through that problem solving a little bit to say, okay, I see a big goal, and how do I break that down into reasonable tasks that we can actually start working on, so that I can translate that to my team and myself to get that done.
So along those lines, I mean, engineers can be pretty opinionated. My experience has been me being an engineer myself, but and you can get into some pretty strong discussions, differences of opinions. What are some of the techniques you use to resolve those differences?
Yeah, you're absolutely right. There can be a lot of very strong opinions, and I do think that working with engineers, I do think that's one of the things that really helps me in leadership is understanding that perspective and being like, okay, yeah, I understand what you're saying, and talking to them about that. I think it helps them at least, realize that I know what I'm talking about as well, and then be able to talk through, okay, well, how does that look? What do we want that to look like differently then? Or trying to talk to them at that engineer level to say, okay, well, what about these things? Have you thought about these? And so having that mentality to say, let's take a step back, and I hear what you're saying, but looking at a little bit of a bigger picture, or maybe opening up their view a little bit to see, okay, it's not just this one issue, or not just you, or not just us. It's here's what we're trying to solve in a more broader sense type of thing.
Do you find there are particular techniques needed when you're bringing, as we started out talking about with acquisitions, bringing in new groups? What are some of the approaches that you use in that regard?
Yeah, I think in that case, and especially with acquisitions, the biggest thing that we kind of deal with when bringing people on board like that is really a lot of cultural differences too. So that's one of the things is you have maybe an engineer, and you are still able to talk in a lot of similar language and around similar topics, but they maybe have a slightly different cultural background than what we maybe have, just based on where they were located in the U.S., the way they were brought up, the way they are handled. So the different techniques there is really just trying to understand that, not just assume because they're pushing back because they want to, but maybe there's an underlying reason to that, or maybe just the way that they are approaching topics or issues that we need to be aware of. And some of the things that we've dealt with is just understanding, yeah, your background, maybe engineers don't like to ask for help, and I think we just see that exacerbated in some of our acquisitions, which is some of those cultures don't like to ask for help. They want to solve it all on their own, and that's one of the things that trying to be more intentional on working with those people, getting in front of them and talking through them, what are the issues you're having, and really not necessarily micromanaging them in that sense, but say, hey, let's talk through what you're really working on, and understand that from a big picture standpoint again.
To me, that brings up one word, and that's empathy. Trying to relate to what their background is, what their concerns in day in, day out. Was there a particular experience you had growing up or in your youth that made you appreciate that approach?
I think really just from the way that as I kind of came into the workforce and industry, and I feel like I had some really good mentors just in my earlier years, just saying, hey, talk to us about what's going on, or let's have these meetings and talk through some of these issues, and really impressing on me that they cared about me more as a person than necessarily just another worker bee who's going to be here sitting or doing whatever it is that I'm doing. So spending more time to get to know that person individually, building that empathy from that standpoint.
Yeah, it's very important. I mean, people can relate if they feel like that's not treating them like a widget, which is, you hear over and over again. Well, a little bit different topic. So what do you do outside of work for enjoyment when you're not thinking about designing products that keep planes flying?
Yeah, the big things for me, I am a really big sports fan. So I do watch a lot of sports, mainly a lot of the college sports, college football, college basketball. So I do love kind of following that. Also a big Formula One fan. That's one of the things I do take a lot of time to watch. I have a little bit of a personal tie there. We do a lot of work with a lot of the racing teams in that world. So being able to say, "Hey, I've got some parts that are sitting right out there on the track today," is kind of a really neat thing. So love watching that. On the other hand, as far as what I do, I also like to participate in those. I wouldn't say I'm an adrenaline junkie per se, but we've talked a lot about something in extreme sports, mainly with something strapped with a board strapped to my feet. Wakeboarding, snowboarding. I love getting out in the snow. Even though I'm from Minnesota, people ask me where I go on vacation in January and February, and I'm saying I'm going out west to the mountains to go find more snow, and they look at me weird.
Yeah. Well, there's a lot of snow in Minnesota, not many mountains though.
Not many mountains. Yep. So we'll do snowboarding, or summers gets nice around here, and you'll find me behind a boat on a wakeboard. So yeah.
That sounds great. So, what about your family? You have kids?
Yeah, we've got me and my wife. We've been very happily married for just over 10 years now. So we have two little ones, two girls, and they are just as busy as can be. So it's it's been very exciting for us to kind of see them grow up. Our youngest now is just about 8 months old. So seeing how she kind of behaves with her sister, and
Uh-huh.
it's been a lot of fun. It's a lot of rewarding experiences there.
Well, that's interesting. I just saw an article the other day about women in engineering. We need more women in as engineers. Do we have two potential candidates there?
I think we do. My oldest, she loves coming to see me at work. She loves seeing what we do. And she tells me all the time, "I'm going to grow up to be an engineer just like Daddy." And I'm like, "Awesome."
Oh, that's awesome. Yeah. Well, I'm glad to hear that. I've tried to convince a number of young ladies and had moderate success in that regard, but that is an important pursuit. Well, listen, Blaine, thanks so much for spending your time with us. I think this is great insights for the audience, particularly as regards operation science and understanding product development in another word, as a production process, because that tends to evade a lot of people. And then when that happens, they ignore the science that describes behavior. And so they end up with a lot of issues they wouldn't otherwise have. But you've provided a great description of your personal journey and some of the learnings that you've had from that. And I think folks listening will take a lot from that. So very much appreciate you participating in the Operation Science podcast and look forward to further communication in the future.
Yeah, absolutely. I really appreciate it, Ed. And I think that it's been a lot of good work that we've done, and a lot of training from you guys. I'm very appreciative, and it's worked really, really well for us at Windings. We're looking forward to the future, and really how we can utilize that in a lot of other areas as we continue to grow our products, our services, our offerings, especially as we go into, and if you haven't heard, we're going into our 60th year of business this year. So this is a really big deal for us. So yeah.
Oh, wow. Congratulations. That is a big deal. And it's an employee-owned business, right?
It is. Yep. We're all in it to do better for not just the company, but ourselves as well at the end of the day.
That's awesome. Well, again, Blaine, thanks for participating, and we will be talking in the future.
Absolutely. Appreciate it. Thank you, Ed.
Take care.
The Operation Science podcast requires more than a conversation. It takes action, research, and collective wisdom. If today's episode resonated with you, we'd love to hear your insights. Join the conversation and help us shape the future together. Join the Operation Science Institute at opscience.org. We'll be back with more stories, strategies, and real-world solutions that are making a difference for everyone. In the meantime, be sure to subscribe, rate, write a review, and share it with someone you think would benefit from it too. Thanks for listening, and see you on the next episode. The views expressed by our guests are their own and do not represent their company's views unless specifically stated as such.